Here we have the trig integral cosine cubed x over the square root of sine x dx, evaluated from pi over 6 up to pi over 3. Now the first thing to do to get this one cracked open is to rewrite how cosine cubed is written. We can rewrite this as the integral from pi over 6 up to pi over 3 of cosine squared x times cosine x over the square root of sine x dx. And now we can substitute cosine squared x for 1 minus sine squared x. So we can rewrite that once more. It's the integral from pi over 6 up to pi over 3 of 1 minus sine squared x, in parentheses, times cosine x over the square root of sine x dx. And now we can perform a standard u-substitution. We can let u equal sine x. The derivative of u, in this case, is cosine x. And now we can rewrite this in terms of u, but only after we convert our bounds. So what we have first is when x equals pi over 6, comma, pi over 3, then u equals, well, when x in sine x is pi over 6, what we have in our triangle is pi over 6 here. Across from it, we have 1. Next door, we've got the square root of 3, and then the hypotenuse is 2. And sine is opposite over hypotenuse, so in this case, u is 1/2. Pi over 3 is this angle here, and sine of pi over 3 is the square root of 3 over 2, opposite over hypotenuse. And so now we're ready to perform our u-sub and change our bounds. So rewriting this, we have the integral from 1/2 up to the square root of 3 over 2 of 1 minus u squared over u to the 1/2 du. And what we can do is we can move this u to the 1/2 up to the top, rewriting it once more as the integral of 1/2 root 3 over 2 of 1 minus u squared times now u to the negative 1/2 du. We can obviously distribute this u to the negative 1/2 across, and we'll rewrite this once more, root 3 over 2, as u to the negative 1/2, and we're multiplying here, so we must add exponents. The exponent of 2 obviously is 4 over 2 minus 1 over 2 equals 3 over 2, so we have minus u to the 3/2 du. And now we just have to integrate. So integrating these with respect to u, we have u to the negative 1/2 plus 1 becomes u to the 1/2 over 1/2, which simplifies to 2u to the 1/2, minus u to the 3/2 plus 1 is u to the 5/2 over 5/2, which looks like so, 5/2 over 5/2. We flip and multiply the 5/2, and we are left with 2/5 u to the 5/2, and this can be evaluated from 1/2 up to the square root of 3 over 2. And so finally, we need to plug in our values. And so we'll start by doing 2 times, and I'll write 3 to the 1/2 over 2, all raised to the 1/2 power, minus 2/5 times 3 to the 1/2 over 2 raised to the 5/2 power, minus, in parentheses now, 2 times 1/2 raised to the 1/2 power, minus 2/5 times 1/2 raised now to the 5/2 power. And it's at this point that things may start to look a little bit overwhelming. And so what I'm going to do is I'm going to go ahead and group some like terms. So what we've got is we've got 2 and 2, and then we've also got a 2/5 and a 2/5. So we'll start by distributing the negative and we'll group them at the same time. So what we've got is 2 times 3 to the 1/2 power, that just means square root obviously, over 2, the 1/2 power. And then we've got minus 2 times 1/2 to the 1/2 power. And then we have once again minus a 2/5 times 3 to the 1/2. Again, that's just a 3 under a radical over 2 to the 5/2 power. And this minus will transfer here to make that a plus 2/5 of 1/2 to the 5/2 power. And so what we can do now to just clean this up is we can pull these 2's out, we can pull the 2/5 out, and we can rewrite it as 2 times, and I'll change this and this to a square root. So we'll do the square root of 3 over 2 minus now the square root of 1/2. And then we can pull this positive out front. We can say plus 2/5 times, in parentheses, 1/2 to the 5/2 power, minus, in parentheses once more, the square root of 3 over 2 raised to the 5/2 power. And this is the final solution to what is a very involved integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.